What's up, guys? Welcome to Meg Talk Science. I'm Meg, I talk about science, and today we are going to be talking about why science can feel so boring. So, for the record, I actually don't think that science is boring. I am somewhat of a neuroscientist myself. I finished my master's degree not that long ago in neuroscience, and I find it all super fascinating and fun. But I know that many people feel like science is just a total snooze fest, so I wanted to talk about why that is. So, let's get into it. So, even though I do find neuroscience really interesting and fascinating, sometimes when I'm reading a bunch of scientific papers, it can still start feeling like a total slog. My focus starts drifting. I think we've all done that. So, my question is, why is that? And I think that the main answer to that question is that science is almost fundamentally inaccessible if you don't have a background in it. So, we're going to talk about that in a second. But for an example, I wanted to show you a video that I made for my master's degree. So this was about a novel neuroscience method and discussing what experiments could be done with it. I'll just show you the first 20 seconds because it is a total snooze fest. But stick with me because we'll talk about what makes it so boring, honestly. Yeah. Designer receptors exclusively activated by designer drugs were introduced by the Roth Lab in 2007. These are a modified group of G protein coupled receptors that can be introduced to neural tissue and activated only by an exogenous ligand, or a designer drug, which was introduced by the experimenters. So, audio issues aside, which I know, I'm so sorry. Obviously, I have upgraded my mic situation since then. This video actually got a pretty decent grade. It got a 17 out of 20, which was a first at St. Andrews, which for my American friends means that it was basically like a low A. So it was a fairly decent example of what the graders actually want from me. And I promise you, it does not get more interesting. So even though I tried to take this story of this method that I actually really think is pretty cool, so basically to give you the lowdown, dreads are a method where we can edit the DNA of an animal and in their brain, and then we can use that edited DNA to make them susceptible to drugs that we add to their system, and then we can turn on or off parts of their brain. How cool is that? We've basically invented mind control, and here I am talking about the viruses that we use to do it. So I think that the problem of making really, really, really cool stuff seem really, really dry is fairly fundamental to at least that video. As further examples of the same kind of idea, I will tell you about my husband. So he did his PhD in computer science not that long ago, and he came to me one day and was like, okay, I've got an abstract, which is a summary of kind of everything contained in the thesis, but in very short form. So he was like, I've got an abstract. Can you read it? Can you check and make sure that all of the phrasing and grammar is good? And I was like, sure, hon, that sounds great. I was excited to learn what he was doing. I started reading it, and honestly, it felt like I was reading another language. It was entirely in English, and I knew a lot of the words going on in there, but I just couldn't put them together. I had no context for that information. So I will read to you a slightly rephrased version of his abstract. This thesis presents the development of a fast and memory-efficient quantile filter, a widely used tool in image processing. A key example is the median filter, commonly employed to reduce noise while preserving object structure. Existing implementations typically optimize for either high performance or low memory usage, but not both. This work proposes a novel approach that generalizes two established algorithms, one prioritizing speed and the other minimizing memory consumption, achieving an optimal balance between the two. And this isn't just limited to things outside of my field of expertise. So for my senior project in my last year of undergrad, I started learning about what my project would be about. It was about attentional set shifting, which I won't go too much into detail. But even though at that point I had already been studying neuroscience for 3 years, reading the background research and the papers required to understand what attentional set shifting was even about felt like going back to middle school and then writing out vocabulary words and trying to define them. It was just an entirely new set of knowledge that I had to learn to even make heads or tails of a single piece of research. So why is this? Reason number one, I would say, and I think maybe one of the stronger reasons that science is so hard to parse, would be jargon. So jargon refers to the use of technical words that are specific to a field. And an example of this is the first page of my master's thesis. So I put it up here, but basically I'm defining neuroscience words for other neuroscientists. So I've got all of my little abbreviations that I'm using in the paper in one place. So you can see we're using things like ADS, antibody diluting solution. I'm talking about CDs, which is a compound discrimination, not the thing you play music on. I'm referring to specific parts of the brain, such as the MPFC, which is the medial prefrontal cortex. And these are all examples of jargon. I'm partially defining them because acronyms can have different meanings in different contexts. So a CD could very well be the thing that you play music on in a different context, but for me it refers to a compound discrimination. But I'm also defining them because some neuroscientists might not work with the parts of the brain that I'm used to working with. So if I refer to the MPFC, I'm very confident and comfortable with what that knows, but not every neuroscientist might necessarily hang out in the prefrontal cortex all the time. So they might need that extra definition. And jargon is good. Imagine if I tried to talk about my research using non-specific terms. I wouldn't get very far. Or for another example, imagine that your plumber came over and didn't know the names of any parts to repair your sink for. He might ask his assistant to go out to the van to get that thingamabob, but no one would really know what he's referring to, right? And so I think that this is a good thing in terms of communication with ourselves, with scientists, but jargon does make science very inaccessible to the public. Okay, so we've got jargon. But reason number two, in my opinion, is that we are trained to see that opinions are sloppy. So for my undergrad, I wrote a 26-page long paper, a research paper with a big, long project involved, just so that I could, at the very end, put 2 tiny little opinions in there. And yeah, in scientific writing, an unsourced opinion is sloppy. You're basically writing an entire research paper so that you can have one opinion, which is very well researched and very well supported, and this opinion kind of becomes a fact through that research. But in non-scientific writing, opinions are ways to inject meaning into a situation. I mean, would you rather see like an analysis of the sound waves of Hozier's newest album? Or would you rather listen to me talk about why I love it so much, using my opinions and my feelings and the emotions that it gave me? I know which one would interest me more. So I think that there's a mismatch in expectations between the public and scientific writing. As scientists, you don't necessarily want to be engaging to anyone but people in the field, and your writing is already engaging to people in the field because of how meaning dense it is. So I think that we as members of the public sometimes will look at the scientific writing and be like, what are you getting out of this? Whereas the science side of it is getting so much out of it. So that brings me to reason number 3. The scientific method is slow. So here's a confession for you guys. I have been on a personal journey to make the perfect chocolate chip cookie for years. And I can tell you that story in 2 ways. I could tell you about how when I started, it was because I had just been getting these really inconsistent results. I would get these perfect, beautiful, wonderful cookies one time, and then the next time I baked, I would get very sad, deflated, basically like, I don't know, hockey pucks, and it very much bummed me out. So I started on this journey of like trying different recipes, learning new techniques, using crazy flours. Moving to Europe was very difficult for my chocolate chip cookie journey because the butter was completely different. So that's basically the interesting version. And ideally, to make it most interesting, you would try the results and be like, oh wow, that's delicious. I could also tell you the technical version, which is that I've been using this brand of butter. I have learned to chill the cookies for this long. I've learned how to use this percentage of these mixes of flours. I've learned how to use this much salt. And one story has kind of an arc, and another story has a lot of details. And those details can be really honestly boring unless you're familiar with baking. And I think that this is why movie science tends to be so unrealistic. So real life involves getting results, changing the experiment a bit, doing it again, talking about what you learned, thinking about how to do it again, and then repeating the process over and over. And this is a good thing. I like that the scientific method is methodical, but it's really, really boring unless you tell the story at a very high level, which can involve oversimplifying. A little bonus reason as for why science might be boring for some of us is the diagram, which is boring but necessary. So here's another confession for you. I'm not a visual learner. I prefer stories, I prefer narratives, and I prefer understanding the gist of something, which then can kind of entice me into learning those details. So learning things like in biology, like ATP production, was really hard and kind of boring for me. I just don't like looking at diagrams and piecing out all the little bits of it. I much prefer narratives. And the opposite might be true if you are more of a visual learner and if you are more of a detail-oriented person. But I feel like for many of us, it's just kind of a slog to learn all those details. And unfortunately, those details kind of make up a lot of science. So yeah, this process is kind of almost unavoidable in a lot of disciplines, and I do feel like that can kind of add in some extra mental effort for many of us. And here's my controversial opinion. I think that internal science communication works the way it is. So if you are in the science community, you will know that there are many problems with academic journals, which we will talk about in another video. But the general system of it, about scientific journals being a way for scientists to communicate with each other, works. Studies don't need to interest me to be important. So I will never be the kind of person who is interested in new developments in organic chemical synthesis. However, if those developments ever do benefit me, I will be very thankful that they happened. Jargon and dry, hyper-specific and technical writing serves a purpose. And training opinions out of scientists until they're earned produces good scholarship. I like that the scientific method is methodical. I think that that's all a good thing. I think that we need a space where scientists can communicate with each other. So what actually does need to change? So what doesn't work and what needs to change is the accessibility gaps in academia. While science, for the most part, works for scientists, there are so many systemic barriers to becoming one for many people. I honestly feel like this conversation wouldn't be complete without discussing accessibility. I mean, guys, disabled people, especially if they're in a wheelchair, can be physically unable to access labs at all. This can mean that disabled people who are wheelchair bound can be out of science altogether despite being perfectly capable of doing it because the lab literally isn't big enough for their chair, right? Personally speaking, I've always been able to do things like have chairs and take meal breaks while doing lab work because I've had a great history of supervisors in the lab and I'm very thankful for that. But that's not true for anyone. Not sitting for hours is common. Skipping meals is common. So if you have anything physically that is different or difficult about your situation, it's going to be really hard to do bench work. Financially speaking, there are so many barriers to the kinds of education that lead to academia, especially if you're talking about getting a PhD. And just generally, unless you're in academia, research is really inaccessible to the public. So you can't scaffold or build upon existing knowledge that is held in research if you don't have the base, which can oftentimes come from an expensive education. And then you also have no access or paywalled access to scientific journals. So this leads us to science communication and why science communication is so important. It's honestly many people's only way to interact with science at all. And that brings me to the main point of this video. The issue isn't that science is boring. The issue is that science communication is boring, and that's bad. So the same training that makes us scientists good technical communicators also makes us very boring public communicators. We rely on jargon, we over-explain, we undersimplify. And the traditional solution has been science journalists. They might do an interview with a scientist and then write about it. And the thing about science journalists is that they can be really inconsistent. Some are great at simplifying and extracting the meaning from a study in a way that the public can understand. And some are the reasons that we have these persistent science myths in pop culture, because while simplifying, the entire point of a research paper can be lost. So if we tried to look at, say, my thesis, even just looking at a reworded version of the title, you would get almost no meaning out of it unless you were fairly involved in the field. So I called it, the reworded version is The Role of the Medial Prefrontal Cortex and the Lambic Reticular Nucleus in Set Shifting, Effects of Chemogenetic Inhibition on Neural Activity and Cognitive Flexibility. And if you just strike out the words you're unfamiliar with, you might end up with the role of blank on neural activity and cognitive flexibility. And that's if you know what neural activity is. So I have had a lot of practice in simplifying my own research topic. And instead of going with almost any of those words, I would have just told you that we as a lab worked on silencing important parts of the brain to understand how they worked in specific behaviors. But that's because I've had years of practice in understanding that. So unless you have a fairly deep knowledge of the subject, it can be really, really hard to simplify like that. But why does science communication matter? I mean, didn't I just say a couple minutes ago that science works for scientists? And while this is true, and it is, of course, important for scientists to communicate with themselves, I feel like the institution of science is there for the public. Discoveries can ultimately be society changing. I mean, projects can be publicly funded, and honestly, communicating discoveries is, in my opinion, a duty that scientists have to the public. This can also foster public interest, which is good for everyone in terms of showing the public where maybe some of their tax dollars are going, and also just getting better funding for something that is fascinating or good for the public. I also feel like good science communication can start fostering a dialogue between academia and science and the public, and hopefully this can maybe push back on some of that anti-intellectualism that we've seen. So overall, science communication is a very important goal to have. So what's my solution to this whole mess? I think that the most important thing in coming up with a solution for it is a dialogue, honestly, between the public and between scientists. I also think that actually video formats and things like video essays can be really helpful and a good way to get across one of the most interesting aspects of scientific research, which is the passion. Researchers are passionate. They have to be. And many of them are quite practiced at explaining what they do, especially out loud to their family and friends, where things feel a bit less edited. Making science more personal or video formatted can also make it more interesting. Why is something important to you? Why is it important to society in general? I think that bringing back the interview between a journalist and a scientist can be a really good way to kind of force people to dumb themselves down and simplify for a lay audience. And finally, I was actually taught how to write lay summaries of papers during my undergrad and grad degree. So this got me in the process of thinking what the public might already know or understand about my research and how I could help them understand more without overwhelming, without using jargon and technical terms, just by explaining what I was doing in a way that made sense. So I think that increasing focus of like lay summaries and teaching scientists how to communicate their ideas can really only help us. My other solution is just accepting that sometimes things can be hard to understand. This doesn't make us dumb, and it doesn't mean that the thing that's difficult is less worthwhile. Accept that sometimes understanding a new topic can be hard. And if it is hard, and if you're interested, you can read around the topic, you can watch a lecture online, and then you can always come back to it later. You can also ask someone, ask a scientist. It's okay to open a dialogue about science. It's much less okay to act like something is stupid or unimportant just because you don't understand why it might be important. There are plenty of things that I don't understand now and I feel like I'll never understand. And I feel like that just adds color to our life. We can't know everything. We have to accept some things. We can ask a trustworthy source and get as close to understanding as possible, but that's okay. It's okay to have to work for something. So, what are my overall thoughts on this issue? Personally, I think that science itself isn't boring, but that learning all the details about a subject can be quite difficult, and it can take a good amount of time. So, it's okay to get a good overview before you dive into something. And honestly, knowing why something is important can make it a lot more interesting. The best science communicators do tend to start with what makes something meaningful or relevant to you. And really, the most important message of this entire video is that curiosity is your best tool when engaging with science and engaging with science communication. Ask questions. If you are interested and curious, honestly, there's nothing that can stop you, to me at least. So I hope that this video was insightful and maybe answered your questions about why science can tend to seem so boring, and hopefully it didn't deter you and maybe even inspired you to go out and learn something new. It's okay to do hard things. You can do hard things. Thank you so much for watching. I'm thankful to everyone who clicks on this video because it means a lot to me. It was really fun to make this and think about all the difficult parts that I have with science. And yeah, hopefully I'll see you next time. So thank you so much for watching, and bye.